Hello, CIS11. In this video, I'm going to go over Lab 9, which was covered on last Thursday. I just want to re-record the video because there was some modification in the code, a very small change, and I want to re-explain the lab so that way if you were not in the session, you would be able to understand. So the next part is we are going to take a look at our lab. You just need to download the lab document from Canvas. And it's going to look like this. So we're given a problem to write an LC3 program that display the day of the week after the user has input the month, the day, and the year. So for example, if you put in the date of yesterday, it's supposed to display the day of the week, which is Friday or Saturday, whichever day that you would be, it would be correlated to the date that you entered. And we need to use the addresses hex 31F0, hex 31F1, and hex 31F2. The hex 31F0 will be the month for our date. Hex 31F1 will be the day, and hex 31F2 will be the year. So as the user enter the date, it's going to store it at these locations, so we will need to fill at these addresses. The example shown here shows the date, June 1st, 2005. And so we would put the month, June, as hex 6 at the location hex 31F0. And then a subsequent location at hex 31F1, we would put the date or the day, which is 1. And then for the year 2005, we would put in the subsequent location. Now, if you take a look at the lab, I actually updated the post and I added some notes for you to see here. That I did modify the data label address location from the prior code that I created. So we would swap the M and the X location so that way it would follow the assignment requirement. And so when you test the program, the example here is April 20th, 2023. For April, you would put hex 4 at F0. For the day 20, you would put hex 20 at F1. And for 2023, you would put hex 20 at F2, which is the century number, and hex 23 at F3. And you need to make sure that you set the value before you run the program. So when you load your program into the simulator, you need to go to this location to put in the date. And it's going to give the out. It's going to show on the console the day of the week. And so now what we're going to do is we're going to go through the rest of the assignment requirement. Just like the prior lab, we're using a value to convert that to the day of the week, Sunday through Saturday. So 0 will be the Sunday and 6 would be the Saturday. And we are going to correlate that with the date that is hard-coded into our program. So when the user enter a date, for example, or we have an input for the date, for example, January 1st, 1900, it should show Monday. Now going through Zeller equation, as you can see here, it shows you F is equal to K plus 13M minus 1 divided by 5 plus D divided by 4 plus C divided by 4 minus 2C. So based on this equation, we know that we would have to operate addition, subtraction, multiplication, and division. So the slash here indicate division. The K in the equation represents the day of the month. And the M is the month number. And so when you are looking at March, April, December, January, and February, if you look, our array of months starts in March, which is 1. And January and February is going to be 11 and 12. So that means that when we look at the month, January and February, that belongs to the prior year. So here we would represent M as X plus 21 mod 12 plus 1. So when we say January X, January X is gonna be 1 as we indicate. So the way that we look at the Western calendar, January is the first month of the year, but based on the equation, when you implement it in, we have to think about how January and February is part of the prior year, or in 11 and 12. So M can be computed as X plus 21, and you would take that to do a mod 12, and you're going to add 1. And so the criteria or the condition for M, we would say X plus 10. If X plus 10, if X is less than 2, then we would take X, we're going to add it by 10. Else, we're going to take X, we're going to subtract 2. So what we would do is we would apply M with the if-else statement. And we would be able to incorporate this equation into our algorithm. The D in the Zeller equation represents the digit of the year. So when I say 2023, 23 are the 2 digits of the year, the last 2 values in the year. And C is a century number. So when I say 2023, C is 20. And so like before, we have to take a look at how F is going to equate out to the string that represent the day of the week. So we would take F mod 7, we would get a value, and that value is indicate the index in our week array. So in this program, we have to implement the subroutine mult for multiplication, as you see in Zeller equation, div for division, that is applied in Zeller equation. We are going to use register 0, register 1 to pass the parameters in our function or in our subroutine. So just like how you're using variables in the parameter when you're passing the variables into the function, we would use these register to pass in our subroutine. And so therefore, we would have register 0, register 1, and register 2 to store the value as the return value for the result. In the next section, it kind of gives you the overall layout of how your program would look. We would have origination address, and we would call our subroutine. We would display the day of the week, and then we would have the data section where we define the days. And remember, we want to make sure that it is aligned just like the prior lab. Otherwise, you are going to have the cutoff. And Wednesday has 9 characters plus a null. So that one is the longest one. And then below the data section, we would define our function definition or our subroutine definition. And from each of the subroutine, we would have the return. And at the end of the program, we will have a .n. So the task for this lab is for you to write the program, assemble the program in editor, and then be able to simulate the program in your simulator or online simulator. We would need to set the value for the month, the day, and the year. And you can test it with multiple dates. I give you the recommendation of the dates here. Then you would also need to answer the questions A, B, C, D as part of D. What output did you get? Is it correct? What new concept did you learn in this lab? And reflect back on how we're using subroutine and parameters and how we implement Zeller equations and incorporate that with LC3. And if you have challenges in this lab, make sure you note that. And in the prior lab, I noticed that some of you have submitted just your code. You don't answer the questions. So please take the time to answer the questions and include your questions with your document where you have your screen captures, which is what I stated below. Make sure that you submit your screen captures and the answer and questions for the lab. This is going to allow me to assess your understanding of LC3 programming along with the problem that's presented to us. And you also need to think about the concept on how this is applied to your project. Next, I'm going to go over the code for this program. And as you take a look at this, I did post the code on the page. So make sure that you refer to this assignment page. And I will include this video onto the assignment page for you to watch in case you want to understand something further. So for the code itself, we are doing lab 9, and you can put the comment Zeller equation for day of the week. Just like the prior program, we would have the origination of address at hex 3000. And in this case, I am using X first, because if you look back into the assignment requirement, it talks about M is equal to X plus 21 mod 12 plus 1. And we have to also set up the condition for M where X is less than or equal to 2 or otherwise. So that means that to start, we need to initiate or initialize that variable. So here we would then load X into register 1. And keep in mind that we need to track register as we go along, and we're reusing some of the register. And on the next line, I'm going to take X, which is in register 1, and I'm going to subtract decimal 2 or add -2. So at this point, what we're doing is we are applying the comparison operator or the comparison assignment operator. What you can see is we are trying to determine if X is less than or equal to 2 by subtracting 2. And so when you take X subtract 2, if it is equal, then it's going to have a 0. If X subtract 2, and if it's a negative, then it is less than 2. So this is why we have -2 plus X, which is in register 1, and we put it on register 1. And this allows us to check for January and February. Remember that we talked about how that can be treated as part of the end of the array from the prior year. So we want to be able to check for that. And so if it is positive, then we know that the month is not January or February. So we would then branch it to not Jan Feb. And then the next part is we are going to add the 12. So here's the decimal 12, add it with register 1, which currently has X, and put it on register 1 as the result. And so this allows us to look at M that is January or February. So when you look at this, right, we are looking at how this is going to be implemented as when you add the 12, that's going to allow us to determine if the month is at the beginning of the year, January or February. And now we would start working with the equation, which is the Zeller equation in purple. That's what you see. So I recommend that you would work outward from parentheses and then work your way to the other variables. Then looking back at the code, we are going to add negative. We're going to load C to register 0. So now we are going to get ready to use C, D, M, K, and so on. So C loaded to register 0. And we are going to take C, we're going to add it with -1. So C is in register 0, so we're going to subtract 1. And why am I doing that? When you look back at the formula, we are going to implement the equation now. Then, because we're using the label not Gen Feb above, right, we are going to get ready to also define that. But before we do that, we need to store out C. When you are reusing the register, and or in the case where C or the value for C can change, you need to write it back out to the memory so that way we can retrieve it later. So for not Gen Feb, this is the label that we previously branched to. For the months that are not January, February, that means it's going to be March through December. Then we are going to define it now. So for not Gen Feb label, we're going to store register 1 to M. And now what we're getting ready to do is this part, 13M minus 1. Then for the next part, we are going to take register 0 and we're going to clear it because we previously used that and we already stored that out, so we can reuse it by clearing it. And then we would bring in 13 to register 0 so we can multiply, because we have to have 13M from the equation. Then after we have the 13 in register 0, we are going to call the function or jump to subroutine JSR mult, because we want to multiply 13. Then we are going to add the -1 to register 2 and put it on register 2, because we want to have 13M minus 1. And remember that register 2 here is going to also have the return value from the multiplication. So when you subtract 1 from it, we're going to have 13M minus 1 when we store it out. Okay, so register 2 actually at this point have 13M minus 1. And we would take that, we're going to store it to a location so we can use it later as a complete equation. We're going to put it on new M. And then we are going to take register 2 and we're going to copy it to register 0 by adding the hex 0. Then we're going to clear register 1 because previously we already stored that out. So then we're going to add the 5 to register 1. Why am I doing this? So let's look at the next part of our equation is that we are going to take 13m minus 1, which we just got, and store out to new m. We are going to divide it by 5. So you got to bring in the decimal 5 so that way you can operate the division with the function or the subroutine. So once I have the 5 added to register 1 and store the result in register 1, I'm going to call on the division function or jump to the subroutine div. And so when you divide, you would have a quotient and sometimes you would have a remainder. And so register 2 is going to have a return value from the division, which is the quotient of m. So we're going to store that to the quotient of m. So quotient of m is going to have 13m minus 1 divided by 5 output. Then next, we are going to take c, which we previously store out here. We're going to load it back into register 0. And we're going to clear register 1 as we previously used it before the function. So we clear it out here. And we're going to take f, hex f, and we're going to add it multiple times. 1, 2, 3, 4, 5, 6. That allows you to have the century value, which we will operate for for century later. So these f's combined is going to give us the 100, because we have to treat the year with an actual value where we want to represent it as 2-digit as a 100 value. Then what we're going to do is we are going to take register 0 divided by 100 to get the year. So we are then again going to call on our division method or call on our division function by jump to subroutine div. And after that, what we're going to do is we are going to store register 0 to D. So register 0 should now have the remainder, which is the last 2-digit of our year. And we need to put that on D as the equation required that D is the last 2-digit in the year. Then we're going to take register 2, which contains the first 2-digit of our year quotient. We're going to store it to new C. And it's important that you do this so that way you write to the memory location where you can later retrieve. Then you're going to take D and then you're going to load it back into register 0. So why am I storing it here and loading it here? It's because I want to now change the value for D. So I need to make sure that I save it and then I would use it to compute. Otherwise, you might affect the actual original value. So when you have a change in value you want to save, which is we're going to do a store and then we're going to reload. So we load D back to register 0 now, and then we're going to clear register 1 because previously we used it to operate the addition for 100, where we add a bunch of F and the hex A here. We clear register 1 and we would take register 1, we would add hex 4 to it. And why am I doing that is because now I want to take D, I want to divide it by 4. So going back to the code, once I have the 4 in register 1, I can then operate the division by calling the function or jump to subroutine div. As we did earlier, when you divide, you would have a quotient. In some cases, you would have a remainder. So that means that it's going to return the value in register 2, and we would take that return value and we need to store it to quotient of D. And so quotient of D would have the quotient of D divided by 4. That's the return value. Now what we're going to do is, because earlier you had the new C here, we store it out. So we're going to reload it back to register 0. And so we would take new C, load it back to register 0, because we're getting ready to do the next part of the equation, which is this and this. So then what we want is we want to take the new C, load it to register 0, clear register 1 because we previously used it before the division method. So we are reusing register 1, so we're going to empty it. And then we would take 4, we add it to register 1, and we would then operate the division. And again, just like before, your return value will be from at register 2. So we would store that out to the quotient of C. And at this point, quotient of C location would have C divided by 4. So once you have all the pieces like D divided by 4, C divided by 4, we would then call the Zeller equation function where we say jump to subroutine Zellers. And so that way we can combine everything together. Now recall that in the equation you have F is equal to K. So we're going to start looking at what F could be. So we would then ask it return the value for F from the Zeller equation, because that's what it is, F equal blah, blah, blah. So your F value is in register 0. That's returned from the Zeller function. And so we need to store that out to F. Now what we need to do is we need to compute the day of the week where we would take F and we're going to mod it with 7. So I need to clear register 1 as I previously used it for something else. And I need to bring in hex 7 to register 1 because I'm getting ready to do the mod. When you use modulus, basically you are operating a division and your output will be the remainder, not the quotient for modulus. So once I have 7 in register 1, I would then jump to subroutine div, which allows me to divide 7 from F. So F divided by 7 at this point. And so we would return in register 0. So we need to store that out to mod F. And so from that point, what we're going to do is we are going to copy register 0 to register 1. And that's going to be the remainder from the F mod 7. So, and we need to bring it to register 1. And once we have that, we are going to allow the value to be able to compute the day of the week. So at this point, we are going to load effective address to register 0 from days, where we define the string for each of the day of the week. And as we do that, we would need to loop until we get the correct day. because it is an array. So we got to make sure that we check. Is it Monday? Is it Tuesday? Is it Wednesday, etc.? So it's going to find the correct day by checking the value based on the remainder that we got from FMOD 7. So we are going to take register 1 and we're going to subtract 1. We're going to decrease until it reaches the negative, as we would go down the list for the day. So when it gets to the negative, it's going to show the day. And we need to bring hex A and we add it to register 0 and put it on register 0 because this is going to allow us to display the characters of the day string. As Wednesday has the most characters, so it's 9 plus 1. That's because of the null. So I have 10 space, and so I need to load it. I need to add it to register 0 and put it on register 0. This is going to allow us to print the characters that represent the day of the week. And we're going to do an unconditional branch back to loop. And for the display, since we branched it earlier, we are going to simply do a puts where it's going to show the entire string, which is going to be the day of the week. And we would halt. So think of this as the main section of your program. Now we are going to define the function as we previously call the function or the subroutine, jump to subroutine. This is now our subroutine definition. For mode, register 0 and register 1 will be your parameters, and the result will be in register 2. So we are going to add 0 to register 0. The reason why we're doing this is we're going to check to see what value it would be in register 0. So when you add 0 to register 0, you can check to see if it is negative or 0. If it's negative or 0, we're going to end the program, because in our case, with the Zeller equation, we want to multiply and our value has to be positive. So if it's negative or 0, we're gonna send it to n. Then we're going to take 0 and add it to register 1. And then we're going to check what's in register 1 again for positive, or near. In this case, we're in a branch for negative and 0. And if the value of register 1 is negative and 0, we're going to send it to n. Then we're going to clear register 2. And we are going to implement the loop for multiplication as we would multiply. Basically, we're adding multiple times. So we would take register 0, add it with register 2, and put the result on register 2. We would then decrease, and we would continue to branch this as long as it's positive. So as we multiply, right, and when it gets to negative, we want to end the loop, and we would return. So this is how we can implement the multiplication simply by adding value continuously, and we will count down. As long as it's positive, it's going to keep looping. If it's negative, then it's going to end, and we're going to return. So this is the definition for the mult function or the subroutine. In the next part, we need to define the division subroutine or div subroutine. So our 0 is going to be your dividend, our 1 is going to be the divisor, and your result is in register 2. Your remainder is in register 0. So just like the multiplication, we need to check register 0. So by adding the 0 to register 0, what's in register 0? If it's negative, we're going to end. we're going to add 0 to register 1, as register 1 is the divisor. You cannot divide by 0. So when it's negative and 0, we're going to send it to N. Now, since division is basically subtraction multiple times, so what we're going to do is we're going to start working with the subtraction operation. So we need to take the divisor, which is in register 1, and we're going to do the 2's complement for the subtraction. We're going to clear register 2 to store the result. And we need to implement the loop as division is subtraction multiple times. I just set this. So we're going to take register 1, subtract from register 0 until register 0 is 0 or negative. So we would take register 0, subtract register 1, and put it on register 0. If it's negative, we're going to end it. If it's 0, we're going to go to diff n or diff n or. So if we use, there's no remainder. And then we're going to add the 1 to the result. Then next, what we're going to do is we are going to make the remainder 0 after register 1 is added. So add register 1 to register 0. And so that way the remainder is then on register 0. And then for diff n, we're going to do the 2's complement of register 1 again to make it positive. And then register 1, we're going to add it to register 0 and store the result in register 0 to check the remainder. And then we're going to return. So once you have the division function defined, then we're going to define the Zeller function or the subroutine. This is going to allow us to combine all the pieces that we have found from the other sections from using the other functions. So now we're going to incorporate everything together. We're going to load K to register 0. We're going to load quotient of M to register 1, which we found for. And so we're going to do this part. And then we're going to add R1 with R0. So that way we would have these 2 pieces. And we're going to load D to register 1. So now we're going to move to this part. And we're going to take register 1, we're going to add it to register 0. So now we have these. Then we're going to take quotient of D and load it to register 1. So we have D divided by 4 here for this. And then we're going to take register 1, add it with register 0 and put it on register 0. So your register 0 has all the prior pieces. We're going to take register 1, which has D divided by 4. Now we're going to load quotient of C, which is C divided by 4 here, and load it onto register 1. And then we're going to add it again to register 0 and put it on register 0. So at this point, we have these. Then after that, we're going to take the new C, which is your C here. We're going to load it to register 1. And since we have to double it, because it's 2C, we're going to take it and add it to itself and put it on register 1. So we have 2C. Then we're going to make it negative because it's subtract 2C. So I would then operate the 2's complement and then add it back into register 0. And we would return. Earlier, we used the N label. We just need to define it as halt. For the data section, again, I want to emphasize that we need to make sure that this is aligned when we define the strings. Otherwise, you need to have all the proper spaces. Otherwise, you're going to have issues with the display of the day. Now, compared to the session that I held in this video, I had swapped the X and the M. So the M field here, M is going to be hex 31 F0, K is F1, C is F2, D is F3, R is F4, and X is F5. Our new M is at hex F6, hex 31 F6. Quotient of M is at hex 3103. Quotient of D is at hex 3104. Quotient of C is at hex 3105. F, I fill it at hex 3106. Mod F, I fill it at hex 3107. And new C is at hex 3108. And we have a .N. So once you have this program in your editor, you would then need to save and assemble. Once you have the assembled program, what you're going to do is you are going to open your simulator, and if you're using the online simulator, you would need to access it and then copy and paste and then have it reassembled, and then you're going to run. But before you run, you need to set your values. So here I'm going to load the program. And before I run, I want to make sure that I set the month at hex 31 F0, the day, and the year. So I'm going to test today, which is April 22nd, 2023. I'm going to go ahead and click the set value. I'm going to jump for the location. I want to put hex 31 F0. And I want to put in the value. So April, we're going to use hex 4. And then for the next location, that's going to be my day. So at hex 31 F1, I would then put down hex 22 because today's date is 22. Click apply. And then for the third location, it's going to be F2. And I want to put the century number here. So 20 for 2023. So the first 2 digits of your year is going to go to F2. And then for F3, we're going to put the last 2 digits of our year, which is 23. And so once you have it, before you run, I recommend that you check X31 F0. We're going to jump to that. I want to see April, which is 4, 22nd, which is 22. And then for F2, it shows hex 220. So let's make sure that we put 20. And then for the year, which is the century, is 20 and the year is 23. So once I have that, I'm going to go ahead and run the program. And I want to open up the console, and it shows the correct day. So this allows me to confirm. I can also check it for yesterday or my birthday, and you would do that. You would use different date to be able to check. So again, what we can do is we need to set the day, the month at hex 31 F0, the day for K at F1, the century, the first 2 digits of your year at F2, and then the actual year value, the last 2 digits of your year is going to be at F3. And this is going to allow you to output the correct day. And so this would conclude my video for lab 9 in CIS11, in which we use Zeller equation to compute the day of the week based on the hard-coded date that we input at the memory location as required in the lab document. And so thank you for watching this video. If you have any questions, please contact me.